So now we're getting to fairly complex programs where you actually really have to think about what you're going to do. You might have found it useful to actually not start with code, but instead a piece of paper. Write down what you want to do first and then try to translate that into code. As programs get more and more complex, this is going to be really useful because if you start with code, you might get lost in the weeds and you can't see the big picture anymore and you will have a hard time getting it to work. In this case, still a relatively simple example. Let's have a look at an example solution for this. Here's my code, and unfortunately now there is so much of it that I can't really fit that into this right-hand pane here all at once without shrinking the font size to something that you can't read anymore. I have wrapped the lines such that the important stuff and the changes that I've made are visible. You can find the complete code in the supplementary material. You might want to have this open so you can follow along on a big screen where you can see everything at once. Okay, let's have a look at what I have done here. First of all, I have to find some new variables. Open angles up here and block angles down here. And this is, as I said earlier already, to keep track of the angles that we have used, because we're now not only interested in one of these. If we have, for example, two openings and we now want to add a block at the next level, we want to make sure that the block doesn't overlap with either of the openings and not just with the last one. So I'm storing these in arrays here. Arrays in JavaScript are very easy to use. I initialize them. This is not what I wanted. I initialize them with these open and close square brackets. That simply means give me an array and there's nothing in it. An empty array in the same way that up here we are creating an empty shape that we're then adding things to as we create our maze. Same idea with these angles. I create an empty array here and an empty array up here. How do I add things? I use the push function. This simply takes the value that is given to this function and adds it to the end of the array. So here I am pushing angle to the end of open angles. Similarly, I'm doing this with block angles here. Okay, what other changes have I made? Now that we know the previous angles, we can actually start to think about how we check for overlaps. Let's ignore this loop that I've introduced here. We will get back to that in a second. I've introduced another variable, overlap. This is simply, as the name suggests, to keep track of whether anything is overlapping with anything else. I'm initializing this to false, so I'm assuming that to start with, nothing is overlapping. And we might set this to true if we do find that things overlap. Okay, then I generate the angle, and this happens in exactly the same way as before. I generate a random number, and I make sure that this is within the right range. And then I check whether I have something that I need to compare to this new angle that I have generated. Here, I'm generating openings. So I need to check whether there are any blocks from the previous level that overlap with them. Now, what is this weird check type of thing here? Well, this is necessary because in the first iteration of this loop, when this code is run for the first time, block angles isn't even known yet. We're only doing this down here where we are creating the blocks. You can imagine that we're out here, we're creating the first outermost layer. There are no previous blocks, nothing is there. So that also means that we don't really need to check for overlap because nothing can overlap with something that doesn't exist. And that's exactly what we're doing in this if condition here. The type of operator returns, as the name suggests, the type of any variable that you give to it. And here we simply check whether the type of block angles is not equal to undefined. In other words, we're checking whether this variable exists. That's all we're doing here. Remember, this is because when we run this code for the first time, block angles is only initialized down here. We haven't gotten to that code yet, so nothing is known about block angles here. Therefore, its type is undefined. If the type is undefined, we are at exactly this outermost layer here, and we don't actually need to check anything because there's nothing that could overlap. If we do have block angles, so we are somewhere in here on one of the subsequent layers, what do? Well, we iterate over all of them. This is this inner loop here. Notice how we're now getting a fair number of nested loops. This is not uncommon in programming. You would have different things that are nested within each other. One particular thing to take care of when you're nesting loops, the loop variables that you're using, the k I have here, need to be different for each loop. For example, here I'm using j. If I also use j here, this would mess up this outer loop. We don't want this to happen, so just make sure that the variables you're using for all the loops are different. Okay, so I'm iterating over all of the block angles because I want to check for every block angle that it doesn't overlap with the angle that I have now generated for the opening. How do I do that? Well, this is this somewhat complex condition here. Let's take this piece by piece. I'm taking the angle that I have generated and I am subtracting the angle of the block that I'm currently considering from it. And then I'm taking the absolute value of that. This is this math.abs function here. In other words, I'm computing the difference between those two angles. And computing the difference, rather than just checking whether they are the same, allows me to introduce a small tolerance as well. As in, even if the angles are very slightly different, I might still want to say that, yes, actually this is an overlap because they are so close that if I generated this, they would still be together. Okay, so I take my difference, and now I check whether this is smaller than this expression here. Okay, let's have a look at that. Let's start from the inside. We have 2 times pi, provided by this library function math, my library constant math.pi times I. What is I? Well, this is the size of our current layer that we have computed up here. So this is the radius. 2 times pi times the radius of a circle. That gives us the circumference. So here I am simply checking how much area, not how much area, but how much length, how much of the circumference a particular angle corresponds to. This will obviously change as we go from the outside of our concentric circles towards the inside, and that also changes our definition of overlap. Out here, if the angles are very slightly different, we're probably going to be fine, just because there's so much space. In here, even if the angles are quite different, there might still be some overlap. This is what takes this into account here. And then I'm adding this, I'm dividing by this constant 1.2, and this is essentially my tolerance factor. I'm adding 20% to this just to make sure that there really is no overlap. Okay, if this condition is true, if the absolute difference between the angle that I have just generated and the angle of the block that I have previously generated is less than this expression here, then I say that there's overlap. And this we don't want. There's another statement here, break. This tells JavaScript to terminate this loop. Stop it right here. You don't need to run the next iteration. Why not? Because we have now established that there's overlap with one of the blocks, or rather at least one of the blocks. So we don't even need to check the others anymore. We already know that this angle is no good. We need to do something else here. No need to check the rest. Okay, so how do I work with this? What do I do if there is overlap? I have solved this in a very simple fashion with this loop here. This is a do, up here, while loop. This means that the loop will be run at least once. You do it at least once. And we're running it while this condition in here is true. In English, while there is overlap, while the angle that I have randomly generated is overlapping with at least one of the blocks that I have generated previously, keep running this loop. In other words, generate a new angle. So this is simply running until we have generated a random angle that is acceptable, as in it doesn't overlap. And the rest of the code is pretty much the same as before. Then I take this angle and I create an opening, and I keep adding openings to my empty shape that I create here, except I'm doing this in a slightly different fashion now because I of course have this variable open angles that has all of the angles in it. So I first create all of the angles, and then down here, I create all of the openings rather than what I was doing before, where I was generating an angle, then I was generating the corresponding opening, adding that to all openings, and going into the next iteration of the loop. And then I'm doing the same thing for the blocks. So this is the same structure as we had before, and this here is again the same structure as what we had up here. We're checking for overlap in exactly the same way, except that of course now we're comparing to open angles. We don't want the blocks to overlap with the openings instead of block angles. So very slight differences there, but the logic that I'm using is exactly the same. And again, I'm also using this do while construct to keep generating new angles until I have found one that is acceptable. And the rest of the code is unchanged. I'm combining everything down here to be able to return it. And because I am not resetting these variables here, open angles and block angles, these will be available in the next iteration of the loop as well. As in, I automatically retain the openings and the angles that were generated in the previous iteration. So starting from the outside of our maze, going to the inside with our concentric rings. And I don't even need to do anything extra for that. I don't need to store that in yet another variable, because as long as I don't change a variable, it's going to stay the same. So that's what I'm doing here. And as you can see, this at least appears to be working. There's no overlap. Let me run this a couple of times just to check a little bit more that this is working as expected. Yes, this looks good. And let's run this again. And let's run this again. Yes, I believe that this is working. Of course, this is only anecdotal evidence. If you wanted to, for example, deploy this code in a safety critical environment, then you would certainly have to do more testing. But I think for our maze generator here, this is sufficient. Okay, and with this, we have a relatively complex example of a program that does something non-trivial and hopefully useful. It generates this maze here and makes sure that between the openings and the blocks that we create, there's no overlap, so that it looks reasonable and is hopefully somewhat exciting and interesting.